Hello students, welcome to Sacred Heart High School. Today we shall study in Science-1, Chapter 12, Study of Sound, Part 2. Our next topic is reflection of sound. Like light waves, sound waves too get reflected from a solid or a liquid surface. These waves also follow the laws of reflection. A smooth or a rough surface is needed for the reflection of sound. The direction of incident sound waves and reflected sound waves make equal angles with the perpendicular to the surface, and all these three lie on the same plane. How much of the incident sound gets reflected decides whether a reflector is a good or a bad conductor. A hard and a flat surface is a good reflector, while clothes, paper, curtains, carpet, furniture, etc. absorb sound instead of reflecting it, and therefore they are called as bad reflectors. Echo. You must have had visited an echo point at a hill station. If you shout loudly at such a point, you hear the same sound just after a little while. This sound is called an echo. An echo is the repetition of the original sound because of reflection by some surface. In order to be able to hear the original sound and its reflection distinctly at 22 degrees Celsius, what must be the minimum distance be between the source and the reflecting surface? At 22 degrees Celsius, the velocity of sound in air is 344 meters per second. Our brain retains the sound for 0.1 second. Thus, for us to be able to hear a distinct echo, the sound should take more than 0.1 second after starting from the source to get reflected and come back to us. Thus, we can determine the minimum distance between the source and the reflecting surface. Thus, to be able to hear a distinct echo, the reflecting surface should be at a minimum distance of half of the above, that is 17.2 meter. As the velocity of sound depends on the temperature of air, this distance depends on the temperature. Echo can be heard multiple times due to continuous or multiple reflections. The Gol Ghumat at Vijaypur in Karnataka is an excellent example of this. Sound waves get reflected from the walls and roofs of multiple times. This causes a single sound to be heard not once but continuously. This is called reverberation. The time between successive reflection of a particular sound wave reaching us becomes smaller, and the reflected sound gets mixed up and produce a continuous sound of increased loudness which cannot be deciphered clearly. This is the reason why some auditorium or some particular seats in an auditorium have inferior sound reception. SONAR is the short form of sound navigation and ranging. It is used to determine the direction, distance, and speed of an underwater object with the help of ultrasonic sound waves. Sonar has a transmitter and a receiver which are fitted on ships or boats. The transmitter produces and transmits ultrasonic sound waves. These waves travel through water, strike underwater objects, and get reflected by them. The reflected waves are received by the receiver on the ship. The receiver converts the ultrasonic sound into electrical signals, and these signals are properly interpreted. The time difference between transmission and reception is noted. This time and the velocity of sound in water give the distance from the ship of the object which reflects the sound, which reflects the waves. So sonar is used to determine the depth of the sea. Sonar is also used to scratch underwater hills, valleys, submarines, icebergs, sunken ships, etc. Sonography. Sonography technology uses ultrasonic sound waves to generate images of internal organs of the human body. This is useful in finding out the cause of swelling, infection, pain, etc. The condition of the heart, the state of the heart after a short attack, as well as the growth of fetus inside the womb of a pregnant woman are studied using this technique. This technique makes use of a probe and a gel. The gel is used to make proper contact between the skin and probe so that the full capacity of the ultrasound can be utilized. The gel is applied to the skin outside the internal organ to be studied. High frequency ultrasound is transmitted inside the body with the help of the probe. The sound reflected from the internal organ is again collected by the probe and fed to a computer which generates the images of the internal organ. As this method is painless, it is increasingly used in medical practice for correct diagnosis. Next, we shall see human ear. The ear is an important organ of human body. We hear sound because of our ear. When sound waves fall on the eardrum, it vibrates. These vibrations are converted into electrical signals which travel to the brain through nerves. The ear can be divided into three parts: outer ear, middle ear, inner ear. Outer ear. The outer ear collects the sound waves and passes them through a tube to a cavity in the middle ear. Its peculiar funnel-like shape helps to collect and pass sound into the middle ear. There is a thin membrane in the cavity of the middle ear called the eardrum. When a compression in a sound wave reaches the eardrum, the pressure outside it increases and it gets pushed inwards. The opposite happens when a rare fraction reaches there. The pressure outside decreases and the membrane gets pulled outwards. Thus, sound waves cause vibrations of the membrane. The auditory nerve connects the inner ear to the brain. The inner ear has a structure resembling the shell of a snail. It is called the cochlea. The cochlea receives the vibrations coming from the membrane and converts them into electrical signals, which are sent to the brain through the nerve. The brain analyzes this signal. Hope children, you have understood sonography, sonar technique, echo, reverberation. Thank you, students.